Okay fellows out there, welcome to lecture 9 module 1 of my video series on introduction to data structures in C, and today we will be talking about a new data type, in fact a user defined data type called as enum. Fine. So in the earlier lectures we had talked about two user defined data type, namely unions and structures. Enum is very similar to that of structure or a union, not in terms of its functionality but in terms that it is a user defined data type. Okay, so the data type is being defined by the programmer. Also in the previous lectures we had talked about hash define macros. Okay, so we had used hash define pi is equal to 3.14, something like that. So we had defined constant in terms of macros and we had used it. Why I'm talking about macros right now at this particular juncture is that enums can be used many a times in place of macros. Okay, having said that, enums are user defined data types and they can be somewhere closely related to macros. Let us actually look into what are enums. The syntax for declaring enum is as given out here. So first we have a keyword called as enum. Then we have a enum tag which needs to be given, and then we have a list of enumerators, okay, which is called as the enumerator list. Okay, so enums basically are also used to increase the readability of the code. Given out here is an example how enum is being defined. Okay, so first I have, as given in the syntax, first I have the keyword enum, then the enum tag. In this case it is the flash error. Okay, this is how the data type is being called. Okay, and then I have the enumerator list. In this case there are two lists, one is defragment error and other is the bus error. So this is how enums are being declared in C. Given out here is a simple C snippet in which enums are used. So first I have the main function. Okay, in the main function there is a user defined data type which is being declared. Okay, so this is the declaration part. This is where you say to the compiler that I have a data type which is of type enum and the name of the data type is days, and this days data type can take this enumerator list or variable list. That is, days can be assigned to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday or Sunday. Okay, the days, the instance that you create from this data type, that is days, can only take up these values. Okay, in this case these 7 values. Going ahead, okay, what is done here is an instance of days is being defined and is being initialized. Okay, so now I have a data type, or I have a variable eday of type days, and which is being initialized to one of these particular enumerator list, one of the values in this enumerators list. So out here the eday is being assigned to a Monday, and then I print the value of what is stored in this variable eday, which is of the type days, which is a enumerator. Then I can also assign the same variable eday to another data list in the enumerator, that is Tuesday. So this this variable eday can take values only from this particular list. You cannot assign this data or this variable any other particular data. So whatever you have, whatever is been declared in the enumerator list, the variable defined from that particular data type of the enumerator needs to be assigned to. And then I go ahead and print out the value of eday after I assign it to Tuesday. And the output of this code would be, to a surprise, that it prints Monday is equal to 0 and Tuesday is equal to 1. So what actually has happened out here is the C compiler actually stores this enumerator list as a series of integer values. so it gets tagged to an integer value. And if you if no tag has been basically given to this enumerator list, the compiler basically starts from 0 and from there on keeps incrementing it by 1. So Tuesday becomes 1, Wednesday becomes 2, Thursday becomes 3, Friday becomes 4, Saturday becomes 6, and Sunday becomes 7. Okay, so then once I print it out, it prints out 0. Okay, and in the next line I have assigned eday to Tuesday, so that prints out 1 as expected because Tuesday is been tagged to 1. Okay, going ahead, let's look at 7 important points which will clear the functionalities of enum in C. The first point that you have to note is that enumeration or in a enumerator data set, constant may contain duplicate values, which means to say that you can basically force this tag to be a constant or an integer, okay, apart from leaving the compiler to do the necessary tagging. Okay, so here I have forced the compiler to tag error to 0. Then what happens to log error? Log error is not being forced to tag to anything, so this becomes 1 plus this, so this becomes 1. And flash error, if I had not forced it to 0, it would have been 2. But here what I have done is I have basically assigned force error as well to be 0 as well. So this is valid in C. Okay, so a enumerator list can be assigned two integer values of the same number, okay, or two integers of similar values, so that is permitted. Point number 2 is enumerator variables obey the scope rules. Now in my later video we will look about what is the scope and what are the rules of the scope. So one has to understand that like any other given variable, the variable or the instance created from the enumerator also obeys all the scope rules of the C language. The third point that here one has to note is an enumerator can be unnamed as well. Okay, so you can skip the enumerator tag and still have an instance of it as given out here in this code snippet. So here I have the main program and here there is a declaration as well as instantiation of the enumerator data type. So the enumerator is there, okay, the keyword enum is there, but the tag column is missing. Okay, it doesn't have an enumerator tag down here. Okay, and then I have a enumerator list. Okay, and then I have an instance error list of this particular type. Okay, so you can afford to skip out the enumerator tag and directly define an instance out of this. So this is valid. Okay, and later in this piece of code, this particular variable, okay, or instance is being assigned to one of the names or values in this enumerator list. In this particular case it is log error. Then if I print out this particular thing or this particular variable or instance, okay, what gets printed out is the name or the number associated with error list. So in this case error list error list is being assigned to log error. So log error is 2, so the value stored in error list is 2. So the output of this code will be the number 2. Okay, rule number 4. Okay, there can be multiple enumerator types in a C code in the same program, but no two enumerator list should have the same name in their list. So out here I have a code which has two enumerators, which is error list and error info. That is perfectly fine, but what is problem out here is both these enumerators have the same name error in them. So this is not permitted. No two enumerators should have the same enumerator variable name, okay, or the enumerator list should not have the same name in two different enumerator types. So this is not permitted, this is wrong. Okay, and you will end up in a error. Fine. Rule number 5, an enumerator tag also follows the scope rule. Okay, so an enumerator tag also follows the scope rule, and tag should be different from that of another data structure. Okay, so we know that the enumerator is a user defined data type. So in this code I have two data types. One is enum of type enum, the other data type is of struct, and both these data types have the same name, that is error list. So this is not permitted, it causes an error. It is very similar to, you cannot have int x is equal to 0 and then int float x is equal to something. So you cannot have int x and float x in the same piece of code. Okay, so this is not permitted. So same thing applies to the enumerator variables or declaration as well. So you cannot have two different data types of similar name. So that is what it implies. Okay, next thing is, if we do not assign values to an enumerator constant, then the compiler automatically assigns value to it. However, enumerator constants can be basically assigned to a integer value, and if you do not do that, okay, it takes, the compiler basically increments the previous value given to the enumerator constant and then increments it by 1. Say for example, out here I have a enumerator days which have the enumerator list or enumerator constants as Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So by default, if I had not assigned any values to this enumerator constants, the compiler on its own would have taken the values as 0, 1, 2, 3, 4, 5, 6 and so on. Okay, fine. Now what is being done out here is, I have forced Monday to have a value of the enumerator constant Monday to have a value of 10. So Tuesday becomes 11, Wednesday becomes 12, Thursday should have been 13 but I have forced it to be 0. So Thursday becomes 0, Friday becomes 1, Saturday becomes 2 and Sunday becomes 3. Okay, and once you print it out, so Monday was 10, so you get 10 as the output. Tuesday, then the enumerator instance, okay, EDA is been assigned to Tuesday, so you print out what is there in Tuesday. So Tuesday is been assigned to 11, so you get 11 as the output. Next you assign EDA to be Thursday. So what was Thursday? Thursday was, this was 11, 12 and Thursday was forced to be 0, so 0 gets printed out. And next EDA is been assigned to Friday, and what Friday gets? Friday gets 1 plus what is there in Thursday, so that was 1, so Friday 1 gets printed out. Okay, so this is the 6th rule of enumerator that you need to take into consideration when you are using this particular data type in C. Moving further, okay, so enumerator constants or the names given in the enumerator list can be assigned only integer data types. So you cannot assign any other floating point number or any other data type to this particular constant in the enumerator list. Okay, and the range of values that you give should fall within the range of or the value that you give should fall within the range of the integer scope on your particular compiler. Say for example, in the compiler that I use, this particular value is outside the scope of a integer data type. Okay, so if you try to assign a value which is outside the scope of an integer data type, you as well get an error. Okay, as when you assign something other than an integer to the enumerator constant or the members in the enumerator list, both are one and the same. Okay, so those were the 7 rules one has to remember when you basically use enumerators in C. Okay, so why do we use enumerators? Okay, as I said, enumerators basically increase the readability of the code. They make your code much more readable and trackable if you are into some kind of a error or debugging kind of a scenario. The other thing is all elements are grouped together, very similar to that of union and structure. It also provides some kind of a data binding, okay, in this particular user defined data type. So these are the two reasons why enumerators are basically used. Okay, enumerators can also replace macros in many of the cases in C. Okay, and they are used for that in many ways. Okay, the other thing that is, as mentioned earlier, is the enumerator tag as well as the enumerator constants follow the scope rules of C language strictly. Okay, this is not true in case of say a macro. The other thing is basically why macros are used, or why macros do exist even when there are enumerators. So in the main reason is, in enumerator you are basically stuck to assigning the enumerator constant or the names in the enumerator list to an integer, which is not in case of a macro. So you can basically have a constant with a float, a character, or even a function for a macro. So that is where macros still have an advantage over the enumerator. Okay, but if you are defining a list of macros which basically take up constants, it is better to go for an enumerator rather than a macro. Okay, that's all for today's folk. Hope the concept of enumerators have become pretty clear to you. Stay with me for my next lecture on this video series. Thank you.